Today's video lesson will focus on translating shapes on a coordinate plane. This is going to be entry number 7 in our math notebook, so make sure to label it properly and to tape in the input onto the left side and output onto the right side. In our first example, we're given a triangle JIM on a coordinate plane, and our task is to translate this triangle 5 units to the left and 2 units up. The first thing we need to do is identify the ordered pairs of the original points J, I, and M. Given that each tick mark on this grid is worth 1 unit, to find the ordered pair or the address of these points, we just need to navigate and count the distances away from 0, 0. To get from 0, 0 to J, we'd have to move 1, 2 units to the right, so that means our first coordinate point would be 2, because the x-coordinate comes first and we're moving along the x-axis, which is from left to right. Then to complete the point, we need to travel 1, 2, and 3 units upwards before we reach the location of J. So that means our y-coordinate is going to be the number 3 because we had to move 3 units upwards, and up or down is a direction along the y-axis. We'll use the same method to get the ordered pairs for the other 2 points. To get to point I, we'd move 1, 2, 3 units to the right from the origin and 1 unit up, giving us the ordered pair 3, 1. For point M, to travel from the origin, we wouldn't have to move anywhere left or right, so that means our x-coordinate for M would be 0. We do, however, need to move 2 units downwards, so that means our y-coordinate is going to be -2 because downwards is a negative direction and we're traveling along that vertical axis this time. Now that we have our ordered pairs for our points of the original shape, we can begin to think about the translation that we have to do to it. Whenever we translate a shape, every point in the shape has to move the same distance in the same direction. That means when we translate triangle JIM, each point J, I, and M will have to move the same 5 units to the left and the same 2 units up. Therefore, another way of writing a translation rule is by writing it like an ordered pair, where we have something being done to the x-coordinate and we have something being done to the y-coordinate. If the rule was to move 5 units to the left, since left has to do with the x-axis and left is a negative direction, we would write -5 applying to all x-coordinates, so we'd have x minus 5, and then the 2 units up is a positive direction which applies to the y, so that means we would have y plus 2 to finish off our rule. So if our original coordinates for J were 2, 3, and the original points for I were 3, 1, and the original point for M was 0, -2, then we'd have to subtract the same distance of 5 from the x-coordinates and add the same distance of 2 to the y-coordinates so that they all move the same amount in the same directions. That's going to give us the new address for our new ordered pair of the image. So our new point J would be J prime, and it'll have the location of 2 minus 5 is -3, and 3 plus 2 is 5, which means our new point J prime will be at, when we count from 0, 0, 1, 2, 3 to the left, 1, 2, 3, 4, 5 up, at -3, 5, that's where J prime will be. The new image for I, or I prime, is going to be at 3 minus 5, which is -2, and at 1 plus 2, which is 3. So I have the x-coordinate -2 and the y-coordinate of 3, which means that when we plot this on the coordinate plane, we'd have to move 1, 2 units to the left and 1, 2, 3 units up in order to get us to I prime at -2, 3. To get M prime, we have to subtract 5 from the 0 x-coordinate, which will give us -5, and we have to add 2 to the -2 y-coordinate to get 0, which means that the new point M prime will be -5, which is 5 to the left away from the origin. And because the y-coordinate is 0, we wouldn't move anywhere up or down, but stay on that x-axis stuck at -5. And that's where the point M prime will be at -5, 0. We can connect these new points together to get our new shape, the new image of the original triangle JIM, now turned J prime, I prime, M prime. True to the definition of translation, the points JIM all move the same distance and the same direction to arrive at the new points J prime, I prime, M prime. Let's work through another example of translating a shape on a coordinate plane. Again, we need to start by finding the ordered pairs or the addresses of the original points of the shape. Point V is 4 units to the left from the origin and 5 units upwards, which gives us an ordered pair of -4, 5. Point B is located 2 units to the left from the origin to give us -2 as the first x-coordinate, and then from there it's located 2 units upwards, which gives us +2 as a y-coordinate. Point S is located 3 units to the right from the origin, which will give us +3 for our x-coordinate, and then it's also located 2 units upwards, which means we'll have +2 again as our y-coordinate. Point Z is located 1 unit to the right from the origin, which means we'll have +1 as our x-coordinate, and then it's located 1, 2, 3, 4, 5 units upwards, which means we'll have +5 as our y-coordinate. The rule that we're looking at states that we want to add 2 to the x-coordinates and subtract 5 from the y-coordinates. Adding 2 to all the x-coordinate means that the whole shape and every point will move 2 units to the right. Subtracting 5 from all the y-coordinates means that every point and the whole shape is going to move 5 units downwards. So if our original point V was at -4, 5, according to our translation rule, when we add 2 to the x-coordinate, that's sliding the point over 2 units to the right, making our new x-coordinate for V prime -2. And then the translation rule for y says we need to move this point 5 units downwards. So we subtract 5 from 5, making our new y-coordinate 0. And so our new point V prime is going to have the coordinates -2, 0. The original point B was at -2, 2, and according to the rule, we need to move it 2 units to the right, which means we added 2 to the x-coordinate to make a new x-coordinate for B prime of 0. The second part of the translation rule says we need to move point B 5 units down, so 2 minus 5 is going to give us a new y-coordinate of -3. So the new coordinates of B prime will be at 0, -3. The original point S was located at 3, 2, and that same translation rule says we'd have to move S 2 units to the right, so add 2 to 3, and that will give us a new S prime x-coordinate of 5. The second half of our rule says that we have to move that S point 5 units downwards, so that would be subtracting 5 from the original y-coordinate 2, and that would make our new y-coordinate -3. So our new S prime point will have the coordinates 5, -3. Lastly, our original point Z was at 1, 5, and again, according to the first part of our translation rule, we need to move that point Z 2 units to the right, which makes it so that we're adding 2 to 1, making our new Z prime coordinate have an x coordinate of 3. And then we need to subtract 5, which means move 5 units downwards. So we have 5 minus 5, giving us 0 as our new y-coordinate. So our new z prime point will be located at 3, 0. After we use lines to connect all these new points together, we'll have the translated image of the original parallelogram VBSC turn into V prime B prime S prime Z prime. Also note how all of the original points moved the same amount in the same direction and ended up the same distances apart from each other. Lastly, I want to go over how translation rules are written. To write a translation rule where we're moving something to the left, then we need to write that we have in parentheses x minus the number of units we're moving to the left. If we want to write a translation rule where we're moving an object to the right, then in parentheses, we'd have to write x plus the number of units we're moving to the right. A translation rule that would describe an object translating upwards or moving up a certain number of units, after the comma, we would have y plus the number of units that this object is moving upwards. A translation rule for an object getting moved downwards would have the format comma y minus the number of units that the object gets moved down. Now apply what we've just learned to the 4 problems on the output. Make sure that you're labeling each ordered pair and writing down the number or the coordinates of the ordered pairs into the parentheses in the proper places.